Hello, Sam fans, and welcome to this Sam Science Physics edition of Gravity and Space, which comes under the astronomy topic. If you are doing foundation or you're doing the combined higher, then you don't need to know this, so please look away now. This is just for higher content for AQA and EdXL. So did you know before Isaac Newton discovered gravity in 1687, people could actually fly? That was actually a real skill. He came along, apple fell on his head. Before you know it, people lost their skill of flying. So really, the gravity is all Isaac Newton's fault. Okay, the solar system. What you should know already is that there are 8 planets in total. I think there's 8 planets in my bit emoji. Yes, there is. Okay, and they orbit a star. So what that is in our solar system is the sun. There are dwarf planets. So basically, a dwarf planet is a planet that doesn't meet a normal planet's criteria of what it needs to be considered as a planet. Therefore, they're just dwarf planets. So they're basically smaller. Moons that orbit planets, artificial satellites. You need to know the difference between artificial and a natural satellite. So artificial satellites include man-made objects and machineries that have been sent out into space. And then you've got natural orbiters, which are, for example, moons and even Earth themselves. The Milky Way is basically a massive cluster with billions and billions and billions of stars, all sort of clustered together. We in our solar system is in the mix of that Milky Way, and what holds those stars together is, of course, gravity. So what's gravity? So gravity is a non-contact force. So what that means is it doesn't need to touch an object for the force to be there. It's caused by 2 masses attracting to each other. So the mass of us as humans and the mass of the Earth causes gravity to be there and take place. Okay, and the acceleration of gravity on Earth is 9.81 ms. So it's usually rounded up to 10. Okay, and you are expected, of course, to know this in the exam. Okay, so gravity pretty much provides the force that creates orbits themselves. Without gravity, orbiting cannot take place. So planets move around the sun in a circular motion. If an object travels in a circular motion, then it's constantly changing direction, which means it's constantly accelerating. So if we take this Earth as an example, the black circle around the sun is the orbit pathway. So what happens at the Earth will go round and round the sun in this normal pathway. Okay, and it's constantly changing direction and it's constantly accelerating as well. Now, the force acting on an object causes it to fall towards the object it's orbiting. So the force here, the gravity itself, is causing the Earth to go towards the sun, hence why the planet can never come out of orbit. Always there orbiting around. Okay, now the orbit keeps accelerating towards the orbiting object, but what takes place is something called an instantaneous velocity, and this velocity occurs at a right angle to the acceleration. So if we take this object here, this is, for example, let's just say this is an object that's being orbiting. You can see here this planet is trying to come out of its orbiting pathway and direction. Okay, but what's actually keeping the planet there in orbit is this instantaneous velocity force, which keeps it in its orbiting pathway. And you can see that it comes in at a right angle. So I've purposely done it in yellow there so you can see it. And it's this force here, this gravitational force here, that keeps it in its orbit pathway and stops it from going out. Now, planets and objects are always going through this process. They're always trying to come out of its orbiting pathway, but then the fact that gravity is there, quite strong, actually keeps it in its pathway. Orbits and speed. So if you didn't know what orbiting means, orbit just literally means an object that goes around and circulates around a particular object within a particular pathway. So the closer you are to the planet, the stronger the gravitational force. So what it means is the stronger the force, the faster the orbiting object needs to travel to stay within the object. Okay, so the force of gravity is strong when you are closer to a planet, hence why we are still able to stand on Earth and we're not floating away. Okay, now if an object is to go any faster, it needs to move orbits. So if the speed of an orbit changes, the size of the orbits needs to change as well. And faster moving objects will need to move to a more stable orbit with a smaller radius. What we mean by stable is that it's stable, like it's not going any far, it's a constant speed essentially. Okay, with a smaller radius. So if we take this picture here, got this planet here, it's in a smaller orbit, but it's going at a speed of 42 kms. Okay, so what that means is it's able to go at a fast speed within the orbit, and all the other objects within that orbit is also fast as well. Okay, if the object was going fast and it was to go in a slow orbit, it would actually crash and bash into other objects. Similarly, like with an object with a slower speed, if it was to go in a smaller orbit, it's going quite slow, whereas the other objects in the smaller radius of the orbit is going quite fast. So what happens is that it will crash into that as well. So orbiting objects need to be in an orbit that has pretty much the same speed as the other objects. So to a lower orbit, the satellite or whatever the object might be will need to slow down so the gravity can pull it towards the Earth itself. Okay, so again, it needs to go in a lower orbit, so a larger radius, for it to slow down and keep up with the rest of the objects. If it was to go a lot faster, then as I said, it will start to bash and crash into other objects as well, because the other objects will be going slower, and if that particular object is going fast, it's essentially going to crash into other objects. Okay, so the things that you do need to know for this particular sort of section of the astronomy is you need to know the difference between artificial and natural satellites, and you need to know examples of them. So natural satellite, for example, is Earth itself and the moon orbits the Earth, remember that, whereas you've got artificial satellites which are man-made and they're sent out into space and they're kept within our orbit, hence why the gravity between the man-made object and the Earth will be quite strong. If that satellite was to go further out of field and out of the orbit, what would then happen is that the gravity field strength would be very, very weak, and then would need to get rockets and other objects sent out there to bring it back in. Otherwise, we wouldn't be able to get back to it. Of course, common thing with man-made objects, it can malfunction and it can break down. Of course, we need to then send people out there, rockets, etc., to go and fix it. You need to know, of course, the different the planets in our solar system, Milky Way, which looked at the beginning, and what it is. You need to know what an orbit is. So an orbit is just the pathway that an object takes that circulates. And of course, you need to know that all objects that circulate go within a circular motion. It doesn't increase in speed, but increases in acceleration. So speed doesn't change, but acceleration increases. And of course, it's constantly changing direction. That is the end of the video. Please subscribe and like this video. And please watch out for any other videos that I may have on astronomy. Thank you, Sam fans.